there's these two fundamental areas of impact. One, this green box, does AI make it easier to collect data? And then the red area, does it help you with analysis and communication and turning data into actions? So on the first one, there are areas where AI can dramatically speed up data collection or reduce low effort to collect data. I'll give a couple examples. So we mentioned one of them, which I don't have an example for, but it's worth thinking about. One of the bottlenecks of data collection is just writing all of these like parsers for all these random file formats in the factory. Like I got my AOI as this one, my SPI as a different one. It changed every model. My text is of this one, and my other punctual have a different one. So you just end up like having to write these fairly straightforward bits of code that read a file or like, and then turn it into something like one turned into. AI code generation is pretty good at that now. I would consider actually quite good at that. So to the extent that that's a bottleneck in your factory, I would consider that as something that AI is pretty good at. It's also easy to validate if it's working or not. It's not running the AI on every single file. It's just making a file parser that you can evaluate if you like it or not, and then choose to use that, to write it manually. But there's another impact as well that I want to call out because it might be less clear that it's also useful. So this is something that I've had to deal with a lot, which is why I particularly like this example. So I'll go into a factory and there'll be some screen or some HMI or some user interface on a piece of equipment, and there's some number being shown on that user interface, and people really want that number, but they want it, in a database somewhere. And so it seems like it should be easy. Clearly the machine knows it because it's shown to me on the screen. I should be able to get it off the machine and put it in a database and then reason about it. But as you know, that's often not the case. So that requires that there needs to be like some file or some interface or some API that also has that number. I've got to develop some software to interface to the API, get documentation for that, read that file. I got to model and understand that, put it somewhere, and then finally I've gotten the exact same key parameter I've already shown on the screen, but I've got it in my database. And this can be like a decent amount of work, including the fact that it might be the case that there just is no publicly documented API for the machine. And so everybody's stuck. And then you talk to the machine's vendor and they tell you, you got to upgrade, you got to buy a new license, you got to do whatever. And now it starts this whole odyssey just to get this number off that's already showing you. So oftentimes these interfaces themselves are web-based. So maybe like the modern, maybe it's a modern SCADA tool that's web-based, or it's actually opening up a web browser. Turns out AI is particularly good at scraping web pages, turning them into structured data, also doing the same thing from images. So just as an example here, this is a particular HMI, happens to be from an injection molding machine, but all these numbers are like, pressures, alarm values that are particularly useful. And those, unfortunately, there's no API that would give this data, even though it's super useful. But this is the kind of thing now that you could just directly plug into your large language model of choice, and then just tell it, hey, here's that image. Take a screenshot, like literally a screenshot of here's the web page. I want you to extract all of the parameters, put them in text table, or put them in XML or JSON, or feed them into my system. And it just runs, and it can very easily sort of interpret them. And this is something that was not reliable, easy to do maybe a year ago, but increasingly, like if it's worth your while, it's pretty straightforward to do now. And in situations where the primary bottleneck was that you just didn't have access to the API, which had the numbers you're looking for, as long as it's being shown on a screen somewhere, it's usually available now, which opens up a whole new set of areas that previously were very challenging for data collection. I'll highlight another one, also on the data collection side. This is one that also I'm particularly excited about because, for as automated as factories are, as automated as some of the equipment is, there's so many things that it doesn't know, right? There's so many things that only a person knows, only the operator of the equipment knows, only someone walking the factory floor knows. And it's historically been challenging to structure like spoken, written, or narrative information from people about what they saw, structured data, structured observations. This is also something that is particularly AI is particularly good at. Hey, take this 5 paragraph or take like a spoken comment, like if someone's walking around the factory and they observe a problem on this feeder and they just say like 30 seconds of what they said. I saw this feeder, here's the problem. Maybe I took a picture, circled the picture, turn that into the equivalent like structured incident report. Could be put in the database, could be linked to that feeder ID, linked to that machine, and then stored for later. I'm not going to do this one as an example, but automated speech recognition, translation, and transcription into written text, and then turning from narrative to structured outputs in a flexible way. AI is also particularly good at, and almost all the models are good at this now, which opens up a whole new set of human collected information that previously was maybe locked in just like written incident reports, or people didn't even write it down because it takes too much time to write the report. But now you can literally just speak a 30-second note and then get the report out the other side as well. So I'll highlight these two as things that to think about. They used to both be doable but challenging, and now they're doable and pretty easy. So you might want to evaluate if the situation where you want to do them. Let me pause here. Any questions on these two, or we'll switch then to the analysis side? Yes.
Yeah, so the AI works well. There is a similar to tool for that work as one French service partial that is a something you expect AI to or something doing.
Yeah. I mean, it depends on how you're using it. I would probably set it up where, so I see it as a category of robotic process automation, just a much more flexible and easier to do version of it. So it's like you identify, okay, I want this bit of information. I want to harvest it every 5 minutes. So I'm going to set up like a script, for example. But what the script is going to do is call the AI to go to this web page, retrieve it, create the structured data, and put it in my database. So you sort of orchestrate around it, but you don't need to parse the web page yourself, or you're write a script to parse the web page. It doesn't matter if the web page changes or it's a weird structure or it's complicated. The AI is able to just handle that as a building block in your overall system. And just to be clear, this is strictly worse than not having to do that, but it's better than it not being possible. So it's sort of like a secondary option versus a primary option, but sometimes it's all you got. And so it's important to have it in your toolkit.
I guess the reason I have the expression is that I use this feature on my own on a lot, and usually I repoke in and front cache errors. Some of the time they miss.
Yeah, no, they do. So, like any OCR type system, like this is why I say it's secondary versus primary, because this translation from, picture or screen capture to numbers, it can have errors, right? There's a non-trivial error rate. It has come down. So I would say we first started doing this maybe about a year ago. And at that point, I would say the error rate was about 1%. So it was like pretty good, but like I do 100 times and I get one number wrong. With the latest models, it's gone down by an order of magnitude. So it's also something that is getting better as the models have gotten better at doing their OCR and image recognition. But again, it's still like 0.1%. So it's a question of like what level of reliability am I looking for versus like, versus what the capabilities of systems are. Okay, so let me do one example here. Okay, so we've got about 30 minutes left. So I'll do this example because I think it shows sort of like the agentic process. So this is a quality investigation. Basically, this is real factory data, anonymized, from a high runner electronic assembly product. So this is it out of an MES. So this is, all along the process route of electronics assembly, from laser marking through screen printing, through placement, all the way through final assembly, and then ICT and functional tests at the end. And this particular product ended up with, high yields all the way through, but in the last step, 87% or 86.5% first pass yield. And obviously there's the problems, high run product, they want to figure out how to get the yield up. But everything was passing except the final test. And so, in the, what do we put together? So you've got like, okay, in the MES, you've got all the product routing data. this is sort of like putting together that piece from all the different data in your factory, the operational data and the context data. So you've got the data in the MES, which is the pass and fail from the final inspection stations, also the defect Pareto. You have all the other machine data, which wasn't in the MES, but in this case, files harvested from inspection equipment, data harvested from pick and place equipments, put separately. And then we asked an AI agent, could you actually find the root cause of this quality issue? So I'll walk through like what we scaffolded and then where we let the agent sort of like live in his sandbox, do his own thing, and then how it all fit together. So first of all, like this was data that was in the MES. This is just like the first pass viewed by step along a single product. And then this defect Pareto also was in the MES. So we, from the MES, you look at it and the top defect causing the low yield was a capacitance issue flagged at ICT. Okay. And you go one level deeper. And in this case, they parsed out all of the ICT files and they knew that the problem was capacitor 413. So capacitor 413 was failing ICT test on this product. That was the primary cause of low yield. But at this point, no idea why, right? Just like a persistent failure is coming. We know kind of where to look, but nothing more. So this is where we gave it to an AI agent to see if it could do it. It was given access to the MES's data to query along the product route. It was given access to all the pick and place data put into a database. It was told that C413 was known to be the top failure for us to investigate. And we gave it access to one work order, basically the name of the work order, so that I could find all of the related assemblies that it might look for. And so in order to like sort of make it visual, like what it's doing, I also had it, I ran it in a special mode where I asked it to like visualize its thought process and print each of the investigation steps it was doing. It's also like watch now how it's investigating. So this is an AI agent. So it's running, in a command line. And I'll sort of narrate through what it's doing. And in this case, I'm playing back the recording of what it did. But if we go through, all it's told is that you've got Redis investigation on C413. You can run Python code if you want, and this is for a demo, so, write a clear visual summary of everything you did. So it goes through, and this is all was told. It goes through, understands the investigation, looking for root cause on the capacitor, decides to write a Python script to figure out what's going on, doesn't have any information yet on where to go, but, writes a Python script. We give it access to a database. It's running some database queries to some orient itself. We gave it one seed work order. We had one seed assembly number. It found all the remaining assemblies in the work order. And now first is like intermediate result 1. It's like, okay, I found the seed order. Now I figured out the 5 work orders we gave it. Here's 37 that it found. Okay, now what does it need to do? It needs to get the defect data and figure out more information and try to link it with pick and place data to identify which feeders and reels were used and see if it was a material related issue. I'm going to run some more queries. None of these queries were given to it, right? I was given a task. I'm going to access the database, decided it needed to run these queries, decided that it needed to pull this data together. So now it's done a quick baseline. It's a high runner product, so it found almost 400,000 units. It found that there were 7,000 erring, 6 of them were defective. Here's the overall defect rate. It confirmed what we told it. And so now what it's trying to do is now it's trying to join the production cycle data from the Fuji machines, which were not in the MES, with the data from the MES by doing like an approximate join based on time, because there is no exact serial numbers. So the same thing that like a person would do if confronted, with this problem. So it goes back, pulls all the Fuji data together, tries to figure out, okay, which exact reels were in use when these boards were run, what's it trying to do? Runs for, a few more minutes. All right.
Accelerate it along here a little bit.
Okay. So, as we mentioned, like from that pyramid of data, not all of the pick and place data was fully like associated with the barcode, but it found pretty good. It was able to get about 95% of these units. It found what the associated placement data was, and actually got almost all of the affected boards happened to be in data so it could find. Found all the feeders in use, all the reels in use, all the nozzles. There's only one vendor of material in that case. There were 5 different lots of material. So now what's it going to try to do? Look at the defect rates and try to split by dimension to figure out what's the commonality. Is it always the same vendor, always the same nozzle, a single lot of material? Is it always a single reel? Is it one feeder? Like, what's the commonality thing that explains the defects? And they go through that process. And so now it goes through it. Yeah. It runs some more queries, break down by dimension, and does a first analysis. So does a first analysis, it looks at it, identifies that there are some feeders that seem to have high defect rate, but it's not fully sure. So it wants to check if perform a control. Literally the exact same lot of material that was placed on 2 different feeders and is a lot bad on both feeders. Okay, it's a lot problem. Is it good on one feeder, bad on another feeder? It's probably a feeder problem. So it goes in, tries to do that split of the data. And nicely considers this the smoking gun evidence. I don't know, AI just like using emojis. Apparently they come from the internet where people like using emojis. But it was able to identify that the exact same lot of material, when placed on a single feeder, had a 70% defect rate. On another feeder had a very low defect rate. Now it goes and does some more confirmations, looks at different reels and different date codes, figures out if there were different, figures out if there's a correlation with the reels. Now it also figures out if, because Fuji serializes the nozzles, figures out if there's a nozzle actually as a problem, or if a given feeder across all nozzles being used showed the problem. To try to, again, partition the space and figure out what the commonalities were. And then pause this. So now it sort of broke out by nozzle, looked at for a given feeder, and then ultimately concludes that the same nozzle only has defects on a given feeder, but not on the other feeder. So it seems like the common cause linking all these 7,000 defects together is which feeder they came from. And it's always that feeder, even regardless of whether different reels are used, the same lot of material is bad on that feeder, good on another material. Nozzles are good on another material, another feeder, but not on that feeder. And so it was able to sort of come back and then provide this particular, this is as far as it was able to get.
Let me what you
So it was able to identify back down a single feeder across all the feeders used in the factory that had an incredibly elevated defect rate and linking to this particular problem. Now, it couldn't go any further than this. It couldn't tell us like why this feeder was bad. It just knew this is where the problem originated. And when I control for everything I can control for, different loss of material, different reels, different nozzles, they all seem to see a split where when this feeder is used, they're bad. When this feeder is not used, they're good. So this is the one common link that I can find. And it did all this automatically, given access to a tool to run queries from the prompting of, here's a work order and look at C413 and figure out why it had a problem. Yes?
Is this in?
We can provide a link to the video, yeah. So I like this one because it sort of like shows, this is the most complicated thing I know that's possible now. Like all the other ones were more like simpler, like single step. It was take this dashboard and interpret it, or pull these numbers out from this, or write me a parser. This is much more open-ended. Figure out how well can you constrain the origin of this quality problem, given that all I've told you is it was C413 and it was this work order, and you can query what you want from the MES and then query what you want from this machine data store. And I mean, let me just talk about impact as well, right? Like at the end of the day, so let me pull back out of this. At the end of the day, if you were to solve that one outlier feeder problem on C413, it's like a 1.6% first pass yield increase. This is a high runner product. Even assuming that this is fully repaired, just the cost of technician repair time in this factory would save you about $300,000 a year because you had 7,000 fewer defects at end of line repair, maybe 15 minutes per repair. That's just that many person hours of time that needed to be used to repair this, and you could have prevented it. And then the point that I would make as well is now, because this system can be triggered from the MES data, hey, whenever I see first pass yield too low and I have a Pareto with one clear, top Pareto contributor, run this and tell me what you found. And then now, as a quality engineer, let me look at all of those pre-triaged potential root causes for all of my products. And now let me figure out, well, which one do I want to go deeper on? But you're not presented just with the Pareto, you're presented with the Pareto linked to, and here's how far we could get based on the analysis. You're starting from a much more advanced place, and now using your human expertise to say, like, no, that was wrong, I don't believe that. But rather than needing to do that investigation yourself, pull it together before you get to that point, that part can be done for you.